Hi, AP Calculus students. Welcome to section 4.4C. As promised, section 4.4 has a lot in it. Now, we're going to look at the FTC on number 2, the fundamental theorem of calculus part 2. This is a problem that will always show up on the AP exam, usually in one place, sometimes two, but most students will get it wrong. And I am here to make sure you don't get that one wrong. And again, you might say, well, why, if it's just one problem, why do we need to do this? Because if you've noticed, I've said that a lot, that there's one of these problems. Now, tangent lines, integration, there's a lot of, but many times I say, hey, there's one of these problems, one of these. That adds up to a lot of problems. We're probably up to about 20 problems now where I've said that. And if you can get these ones right, that's what gets you a 5, right? And that's why I'm here, okay? So here's the basic idea. The symbols look like a lot like, oh no, what is this? The execution of it is actually easier, right? That is different from 4.4a. The idea behind integrating f of x from a to b, capital F of b minus capital F of a sounded easy, right? It was in the execution, it was hard. In this one, the execution is easy, but I need you to be super, super careful. And by that, I mean right there is what I mean. Okay, here we go. So here's the basic idea. If you have an integral of g of t d of t, notice I'm using inputs of t, and that integral is being evaluated from a lower limit or lower value of a. Now, that lower limit must be a constant. If it is not, you in fact cannot use FTC number 2. And they may do that to you on the AP exam. So you have to check. You have to check some things to see if you can in fact use this, right? Okay, so if the lower limit is a constant and the upper limit is a function. Now, it could be with the x input. It could be a super easy function. It could just be x, right? Then if you have this integral and you are taking the derivative of it, first of all, you do know that they are inverses. The integral and the derivative will cancel. It will leave you then, when they cancel, the inside function evaluated at the upper limit. You will be left with the function g, because this and this canceled, with the upper limit in it, not the lower. We'll see why later. Multiplied by the derivative of the upper limit, the derivative of the inside function. Okay, why? Because if you actually were to integrate and then take the derivative, you would have the chain rule right here, and you would have to have the derivative of the inside function. Okay. Ask about this. Again, this is what students will forget. They will remember to put sine into this function here, but they will not remember to multiply by the derivative of sine, which is cosine. That's what they will forget. Please do not forget it. Okay. All right. So you may be saying then, well, then why? Why do we do this? Why do I even have to know this rule? Can't I just integrate and then take the derivative? Like, can't I just do it in steps? No. What the AP people will make sure that happens is they will give you an expression that you do not know how to integrate. You do not know how to integrate sine of t squared. You do not have a way to integrate that. So you cannot integrate this and then take the derivative. They want to make sure you know how to use this rule. Now, if this upper limit f of x happens to just be an x, then what happens is, and I wrote this in a different way, I want to make sure you can see different forms. This is still the derivative with respect to t of the integral. These are still a derivative and an integral. They will still cancel each other out. But you will be left with then, the function will be left over, evaluated at the upper limit. You will simply be left with f of x. Why is that? That is because the derivative of x by the chain rule is 1, and you don't need to show multiplying by 1. Okay, so number 2, why? Why? Because the integral and the derivative are inverses of each other. And B, if you could integrate and then take the derivative, this FTC number 2 would be your result. It's true. It's a truism. It works every time. And in fact, we will do that on 6A. We will take the integral and then the derivative, and you'll see that we get 2x left, what this rule says that we should get. So we've already covered number 3. So why not just integrate and take the derivative? AP will make sure that you have an expression you do not know how to integrate. Now, let's take a look at number 4. What the heck is the difference between f of t and f of x? Well, f of t right here, if you just looked inside here, you would say, oh, you know, if I had f of t, I could draw a picture of that, right? That's an area. So that's what I did over here. Let's say f of t is 2t. So I drew it, right? From 0 to 5 and then from 0 to 10. Here's the t-axis, and here's the value of the function f of t, and I drew f of t. There it is, right? So this is f of t. When you integrate f of t, right, you get f of x. So what is f of x? How is it different? We know that an integral shows as the area between the function and the x-axis. So this area right here, that area function is f of x, and it in fact equals x squared. Let's take a look right here. Let's, right here, this triangle right here, from 0 to 3, this is 3, base of 3, height of 6, that's 18, and then half of that is 9. 3 squared is 9, right? This is, and certainly it's not the function 2t, it's a different function, it's x squared. Let's take a look here. This area from 0 to 4, that's 4, 8, that's 32, half of 32 is 16, 4 squared. Without a doubt, these two functions are different. Okay, 5, why does the upper limit, f of x, or right x, show up in the final answer, but not the constant a? Let's find out. Okay, now to use this theorem, you have to have a constant as the lower limit, okay? But it won't show up in the final answer. So here's what we're gonna do. I know, according to this theorem, that when I have the derivative of an integral and the lower limit is a constant, that I can just, the answer will be the function evaluated at the upper limit. I should get an answer of 2x here. Let's put that up in the corner. Okay, now this is something though that we do know how to integrate. So let's go ahead and integrate it and take the derivative of it and see if we get this answer. Okay, you know the integration of 2t is t squared, and we'll evaluate that from 3 to x, right? Let's do our f of b. That is x squared minus f of a, 9, right? There's the integral. And now I have to take the derivative with respect to x, and I get 2x. There we go. So we were, in fact, the FTC does work in that case. Notice that this lower limit of 3 does not show up in the final answer. Okay, let's take a look at B. At B, I see an integral. I see a derivative. I think this is FTC number 2. Let me check the lower limit. It is in fact a constant. So I know what I will be left with is the function evaluated at the upper limit. times the derivative of the upper limit, and that was just a 1. Let's look at C. I see a derivative in an integral. I believe this is the fundamental theorem of calculus 2. I check to see if I have a lower limit that's a constant. I do, it's a 2. What happens if the lower limit is a constant? You cannot do it. Cannot. Okay, second time I said that, just, they may do that to you. Okay, so I know then that I can use FTC number 2. The derivative and the integral cancel out. I'm left with the original function evaluated at the upper limit times the derivative of the upper limit. And I would prefer that that 2x go in front of cosine x squared so it doesn't look like 2x is part of the angle. Okay, most students will forget the 2x. This will be a multiple choice question. This will be one of the answers, and a lot of students will pick it. You now know that this is the answer. Okay, last time here. Integral, derivative, lower limit is a constant. It will be, I will be left with the function with the upper limit inside of it. So 4t will be sine cubed x times the derivative of the upper limit cosine of x. You will not forget this. Other people will. And we are done with section 4.4. It's a lot, isn't it? Have a good day.